Hello friends, and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds the number of leaf nodes in a binary tree. First, let us make it clear what exactly a leaf node in a tree means. A leaf node is one which has no child. Let us consider this tree for example. In this tree, nodes 1, 11 and 4 are leaf nodes as each of them has no child. Hence, the count of leaf nodes here is 3. Now, let us see the algorithm which will assist us in finding the number of such nodes. Note that we are using a queue data structure. Also, we need a count variable to store the number of leaf nodes. We initialize the count to 0. Let us also have a sample tree to test our algorithm. We begin with step 1 and push the root node, which in our case is 1, into the queue. Since the queue is not empty, we enter the while loop. As we enter the loop, we dequeue the node already present there in the queue and assign it to temp. Here, 1 will be dequeued and hence temp will point to 1. Now we will check whether temp is a leaf node or not. If it is so, we will increment count. So, leaf node is one which has no child. In our tree, nodes 4, 5 and 3 are nodes which have no child. We will use the code given in the right for this. Let us see the first if in the while loop. Right now temp is 1. If temp left not equal to null, which in our case is true as temp has a left child which is 2. So we will push 2 into the queue. Next, if temp right not equal to null, which is again true as temp has a right child as well, which is 3. So we push the right child into the queue. The third condition is not satisfied as temp left and temp right are not equal to null. So the value of count will not be increased. As you can see, the left and the right child of 1 are enqueued. Since queue is not null, we loop. Again, we dequeue the node from the queue and assign it to temp. Here 2 will be dequeued. So temp will now be 2. Again, we check the first if condition. Here 2's left and right child both exist, so it is not a leaf node. Moreover, 4 and 5 will be enqueued. Since queue is not null, we loop. Now 3 will be dequeued and assigned to temp. Again, we check if 3 is a leaf node or not. Since 3 has no child, the third if statement is satisfied. So the value of count is incremented by 1. Again, queue is not null, so we enter the loop and 4 will be dequeued. Now 4 is a leaf node. As you can see, 4 has no child. So the value of count will be increased by 1. Then 5 is dequeued and assigned to temp. As you can see, 5 has no child. Hence, it is also a leaf node. So the value of count will be increased by 1. Now the queue becomes empty and control will come out of the loop. So the final value of count that will be returned is 3. Now let's have a look at the time complexity of the program. This code will run in big O of n complexity, where n are the number of nodes in a tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.